address space. So for the parent, so this is the parent process address space. So a clone will be created. So when you are invoking, when the parent process invoking the fork system call, for the child process, a copy of the address space similar to the parent process created. So the copies of the memory segments are identical for both parent and child. The new process has copies of parent's data stack, allocated variable, open file descriptor, etc. So when you are invoking a fork system call by the parent process, a child process will be created and the parent process address space. Similarly, it is created for the child process. So parent and child having address spaces. Okay. So this is by using fork system call. Here we have an array. After that, we have some set of variables. Here you are invoking the fork system call. So after invoking the fork system call, what will happen? This is one process. A copy of the process will be created. That is called a child. For child, what will be the value by the OS for the child? What will be the value for the OS by the OS? For the child, what will be the value by the OS? Anyone?
0.
0. Good. And for the parent? For the parent?
Process child.
Child ID will be written. Okay. So when you're executing this program, for the child, 0 will be written by the OS. And for the parent, child ID will be written by the OS. Okay. So here is the copy. This is one program, one process, and this is another process. Okay. So this is our original program. When you are executing, it become a process. A copy of the program will be created. Okay. So here we have one copy and we have another copy. So in this part, for the parent, child ID will be returned. So n value is nothing but this is parent process. So n value is greater than 0 means that this is parent process. So child ID will be returned to the parent. So child ID is greater than 0. So this part is parent process execution. And coming to this one, this is child process. So n is greater than 0, condition fails means that n is equal to 0 means this is child part. So for the parent side, this part gets executed and child part, this part gets executed. So here in the parent side, this side we are executing. So parent process, we are printing sum of even numbers. So by using for loop, we are summing the even numbers here, parent side. So finally you are displaying parent process, sum of even numbers. What is the value? After that, child process executed. Here this performs sum of odd numbers. So we are printing child process, sum of odd numbers. See the output, child process, sum of odd numbers. So this is how the fork system call executes. So either parent process first executes or child process first executes. The order of execution is not fixed. So the order may be anything, either parent or child. So concurrently it will be executed. So the output may be anything. First child will be executed, then parent will be executed, or parent will be executed, then child will be executed in case of fork system call. Now, by using bfork, how it will look, we'll see. So bfork create a child process and block the parent. So in case of fork, it creates a child process. Both the parent and child executes concurrently. Whereas in the case of bfork, it creates a child process, but it blocks the parent. So first child executes and then only parent will be executed. So here bfork creates a new process as this fork, except that the child process shares the same address space as the calling process. In case of fork, separate address space is created for child. Whereas in the case of bfork, same address space is shared between the parent and the child. That is the difference. So two difference. One is parent will be blocked in the case of bfork. Second one, same address space of parent is utilized by the child. This is the second difference. So you have to include this header file for to make use of bfork function. What is the return value? Same thing. It returns 0. Sorry. It returns 0 to the child process and for the parent, child ID will be written. Return value is similar to fork. In case of error, no child will be created. So the format is vfork, open and closing parenthesis, semicolon. The same format. Int variable is equal to vfork, open and closing parenthesis, semicolon. Here is an example program by using fork system call. So here, parent to display the odd numbers and child to display the even numbers. See here, we are using fork system call. We are checking whether child is created or not. If it is created equal to 0 means child is successfully created. So child will print the even numbers and the parent will print odd numbers. Okay, see the output. Both are executing in parallel. Concurrently, both parent and child are executed. See the output. Whereas here we are using v4 instead of, in the previous program we used fork here. Instead, I just changed this as v4. Remaining things are same, similar to the previous program. So parent to print the odd numbers, child to print the even numbers. See the output. So first child is executed until that parent is blocked. Then the parent will be executed. Is it clear? Is it clear? If yes, type single S in the comment section. Okay. Now coming to the difference, fork versus vfork. So fork, either child or parent process will execute based on CPU selection. So in parallel it will be executed. So either child 1 or parent will execute based on the CPU selection. But in v4, surely child will execute first. After child terminated, parent will execute. So first child will be executed till that parent is blocked in the case of v4. So here the difference is given. So modification in address space. In case of forks, it is not visible because both parent and child use different address spaces. So here any modification done by the child in its address space is not visible to parent process as both will have separate copies. Whereas here it is visible as it is working on the same copy of the address space. And then address space, both having different address space, whereas here same address space. And then execution summary, both execute simultaneously, parent and child. Here parent is blocked till the child completes. Okay, so this is the difference between fork and vfork. Hope you are clear with this. If you are clear up to this, type double S in the comment section. What about others? Okay, next one. Now we are going to see in detail about execute function. So last class we discussed about execute L function. Only a single function we discussed. So we have a family of exe functions. So that we are going to discuss now. So what is mean by exe function? So when you are executing a program, it become a process. So when one process is in execution, how to load another process into the running program by replacing the existing process. So how a program loads into a process. So here our aim is to load another process by replacing the running process. Okay. So that we can achieve by using exe function. So when a process calls one of the exe function, that process is completely replaced by the new program, and the new program starts executing at its main function. So simple example, we are running an addition program. I want to replace it by multiplication program. So that is possible by calling this exe function. So when I am calling this function with the multiplication program, the previously running program is replaced. Addition program is replaced with multiplication program. But the process ID does not change. You are just replacing the current program with new program. Okay. So already an ID will be allocated for the running process. The same ID will be retained for the new process. Okay. So the process ID does not change across an exe because a new process not created, it just replaced the current process. Its text data, heap and stack segment with a brand new program from disk. So here you are just replacing the current process with a new process. Then the exe family function replaces the current running process with a new process. Same thing, you have to include this header file or to make use of this exe function. So this is the exe family function. Totally we have 6 functions. So this is what we discussed in the last class, exel. So here it will be having different formats. That is the difference. So here all 6 written minus 1 on error. On success no written. Okay. So we'll have difference among the functions. So the first difference is these functions first 4 take path name as argument, whereas the last 2 take file name as argument. So if you take the first 4, we have path name as argument. This is file name as argument. So that is the first difference among the 6 functions. Second difference. So the next difference concerns passing of argument list. So here L specifies list. We are passing the arguments in the form of list called L. If you are passing the arguments in the form of array, that is called a vector V. So passing of argument list, L stands for list and V stands for vector. Vector means nothing but array. Then the function exel, lp, le requires each command line argument to the new program to be specified as separate arguments. So L, LP, LE. We will be passing the command line arguments in a form of list. Okay, so in a form of list means that A, comma B, comma C, like that. Separated as specified as separate arguments. Whereas here, if you take EXE, V, VP, VE, in this we are passing as array. So build an array of pointers to the arguments. So how the arguments are passed to the function. So here if you are passing the arguments in the form of list, that is called these three, L, LP, LE. V, VP, VE for array of pointers. We are passing as an array of pointers as arguments. Okay. Then the third difference, next one, the final difference, passing of environment list to the new program. So how we are passing the environment list? That is the third difference. So allow us to pass a pointer to an array of pointers to the environment string. So here the two functions whose name end in LE, VE. So here LE and VE pass a pointer to an array of pointers to the environment string. The other four functions, however, use the environ variable. So for to pass the environment list, we can use an environ pointer or you can use an array of pointers, right? So these two uses array of pointers, LE and V, array of pointers, and another one, other four uses environment variable. Environment variable in the calling process to copy the existing environment for the new process. So there will be three difference among the six function. So the first four take path name as an argument, last two give to file name as argument. And then how we are passing the arguments in a form of list or vector. So that makes the difference. So here if you use the term L, LP, LE, then it passes the argument as list. And V, VP, VE, it passes an argument in a form of array, vector. And the final difference, how we are passing the environment variables, either in the form of two environment variable or array of pointers, environment pointer. Okay, so that makes the third difference. So here it is a consolidated slide, nothing else. Now, coming to exe function, when a process calls one of the exe function, that process is completely replaced by the new program. So it starts executing at its main function. The process ID does not change across an exe because new process not created. So it replaces the current process. I told you already, we are running an addition program. During execution of the addition program, I can replace it with the multiplication program. So the process ID remains the same. It will never change. So now coming to the difference in a tabular format. So EXEL, what it uses, path name, then argument, list. So path name, argument, list. Then it uses environ variable to pass the environment details. Then if you take LP, file name as argument, LP, file name as argument, argument list. File name as argument, argument list, it is also uses environ variable. If you take LE, here it uses environ pointer, path name, then argument list, environ pointer, path name, argument list, then environ pointer. So here the letter P specifies file name, L specifies list, V specifies it is a vector array, E specifies environ pointer. That's the meaning. So we are using LE, LP, LEV, VP, VE. So here, what is the meaning of that letter? P specifies file name, L specifies it is an argument list, V specifies it is a vector array, E specifies environment pointer in the form of array. So here is the difference among the six execution functions. If you are clear up to this, type singulars in the comment section. Okay, now we'll see an example program, exevp. So all the six function tasks, the running process will be replaced by a new process. That is the meaning. All the six purpose is same. Running process can be replaced by a new process. So here, created child process does not have to run the same program as the parent process does. So what parent process executes, the same process need not be executed by the child. So the child can execute another process. That is the meaning. So here is the format is given. So the first argument file represents the file name which you want to execute as a new process. Then argument V specifies array of character pointers. So now we'll see an example program. We have two programs called exec.c and exedemo.c. So here we'll replace, we are going to execute the parent process, this one, demo.c. So this is replaced by the child process, namely this one. Okay, by executing BP system call. So this is parent process replaced with this child process by executing this function. So here this is the program of this file exe.c. So this is the child process and this is the parent process demo.c. I have named it as 11.c. Okay, see the side how I have compiled. So I have compiled the child process separately, namely exe. An object file is created with this name. Then this is the parent process 11.c with the name p I have created. Now I am executing the parent process. So when I am executing the parent process, see the statement here. This is the parent process. We have argument. What is the argument set? We are passing the file name. Then null. No arguments we are passing. Simply we are passing object file name. This one. So this is object and list of argument is null. That is set as arguments. Then here we are invoking exevp. We are calling execute function. So when I am executing this program, argument s of 0 is nothing but this one. Then argument s, the remaining set of argument is null. So we are passing this object file name to this. So when I am executing this one, exe will be called. This object file is called. So control goes here. Printf I am exe.c called by exevp will be displayed new line. So you'll be getting this output. So this program is running. So you'll be getting this output so that this printf statement will not be executed. So here itself we invoked exevp. So this running process is replaced with the child process so that the remaining statements in the parent process will not be executed. So this printf statements will not be here. So this part is skipped. So the remaining statements of the parent will be replaced by the child. So this child process replaced the parent. So this statement is printed here. If you are clear up to this, type double S in the comment section. Okay. Same thing explanation is given. Same next one is V. EXEV. So the format is purpose is same. So this is very similar to EXEVP function in terms of syntax as well. So format is path name, then argument vector. So here this is path name, which object file you want to execute, which child process you want to execute. That object file you have to pass. Then argument V is nothing but it is a null terminated array of character pointers. Same program, demo, parent process, this is child process. We'll replace the parent process with this child process by calling this function. So this is child. Again the same set of code. This is parent. So here again we are calling the object file name. So this is argument list. By using exe instead of bp, we used to be. That's it. Again I am passing the object file name here, comma. It is a null pointer. So argument s is the remaining set of arguments. It is null. So when you are executing this program, up to this it will be executed. Automatically control goes to the child. So this part will never get executed. So this ending, this statement will not be printed by the parent. So this one will be executed by the instead of parent. This program will be executed. Same explanation is given here. Then coming to LP and L. So these two also serve the same purpose. So all the six functions perform the same thing. It replaces the running process, that's all, with a new process. Only the difference is how we are passing the argument list. Syntax is different. So this is for LP and this is for L. Here you are passing file name as an argument. Here path name as an argument. And we are passing argument list. So it replaces the current process with a new process. And coming to VE and LE. Here you are passing environment pointer. That is why we are using V here. Environment pointer. So this is for ESC V function format, LE function format. Here you are passing file name as an argument, path name as an argument vector. Here it is argument list, but in both case we are passing environment pointer to pass the environment variable list. That's the difference. Are you clear up to this? Type single S in the comment section. Okay. What about others? Okay. Okay, we'll stop here. We'll continue in the next class. Take care. Bye.